When we think about our modern world, things like computers, space exploration, super advanced materials, we tend to think it all just popped up in the last century or so, right? But what if I told you that the roots of all that technology stretch back thousands of years? Today, we're going to dig into some of these ancient innovations that secretly, kind of quietly built the world we live in now. We're talking everything from the code in your phone to metals that literally defy time. I know, it sounds a little bit like science fiction, right? But seriously, what if the code for your computer was actually written back in 300 BCE? The fundamental idea behind all modern computing, that binary system of ones and zeros, was first laid out over 2,000 years ago. It's wild. And to really get how that's even possible, we got to start with the language that underpins everything.
And that language is the language of numbers. See, the foundation for so many of these breakthroughs was this truly revolutionary way of looking at mathematics, or Ganita, the science of computation. And this wasn't just, abstract theory for scholars. It was a super practical tool they used for everything from day-to-day business to charting the stars.
And really, it all starts right here, with this one deceptively simple idea. A concept so powerful it would completely change the game for science and math forever.
So the real genius behind shunya, or zero, wasn't just thinking of it as a placeholder, like the 0 and 101. The breakthrough was treating it like a real number with its own rules. The mathematician Brahmagupta, way back in the 7th century, was one of the first people to actually write down the rules for it, like what happens when you add 0, or subtract it, or multiply by it. It seems obvious to us now, but back then, this was a massive, massive leap forward in thinking. And this right here really shows you how powerful that leap was. I mean, look at the left, Roman numerals. Just imagine trying to do long division with those things. It's a nightmare. But on the right, you've got the Indian decimal system. Once you combine 0 with a place value system, where the position of a number matters, well, suddenly all those crazy, complex calculations become simple, elegant, and you can scale them up to any number you want. It was a total game changer. And look, this wasn't just a one-off fluke. This timeline shows a long, continuous history of incredible innovation. We're seeing the Pythagorean theorem being used centuries before Pythagoras was even born. We see them developing detailed trigonometry. And then you get to the Kerala school, and wow, they're working with infinite series, the very stuff that modern calculus is built on, hundreds of years before guys like Newton and Leibniz came along in Europe. It's just amazing. Okay, so remember that computer code from 300 BCE I mentioned at the start? Well, here's the story. There was this scholar named Piṅgala, and he wasn't trying to build a computer. He was studying poetry. He was looking at poetic meters and classified syllables as either long, or guru, and short, or lagu. And then he had this brilliant idea to represent them as 1 and 0. And just like that, he created the world's first known binary system. Not for a machine, but to figure out the mathematics hidden inside language. How cool is that? So now that they had this incredible mathematical toolkit, they didn't just use it for problems here on Earth. No, they pointed it upwards to try and decode the biggest system of them all, the cosmos. This was the science of Jyotisha, ancient Indian astronomy. Get this, over 1,000 years before Copernicus started making waves in Europe by saying the Earth revolved around the sun, the Indian astronomer Āryabhaṭīya wrote this down. He said the Earth is a sphere, that it rotates on its own axis, and that this rotation is what causes day and night. For 499 CE, this was an absolutely revolutionary way of seeing our place in the universe. And this wasn't just a minor tweak. This was a whole new way of thinking. Āryabhaṭīya was basically saying, hey, let's move past the old myths. He argued that eclipses weren't caused by some celestial demons swallowing the sun. Nope. They were caused by shadows, the Earth's shadow on the moon, or the moon's shadow on the Earth. It was a purely scientific explanation based on observation, math, and geometry. And again, all this deep knowledge about the stars wasn't just for academic debate. It was super practical. They used it to create the Panchanga, which is this incredibly precise and detailed calendar. It tracks the exact movements and the angles between the sun, the moon, and the constellations to organize time. It's a system so sophisticated and accurate that it's still widely used all over India today. Okay, so we've talked about abstract code and these huge cosmic models. But what about the stuff you can actually touch? The tangible technology. What things did they actually build? Well, this is where ancient India's mastery of metal and material science just really, really shines. Let me introduce you to Wootz steel.
This stuff was basically an ancient supermaterial. They made it in these special sealed pots called crucibles, which resulted in a high-carbon steel that was famous for being incredibly sharp, super strong, but also flexible. It was so sought after, it was exported all across the ancient world. And it's the very same metal that was used to forge those legendary wavy-patterned Damascus swords.
So if Wootz steel was all about having a sharp edge, this next thing is all about endurance. What you're looking at here is a 6-ton pillar. It's made of almost pure iron, and it's been standing out in the open, exposed to the weather in Delhi for 1,600 years. 1,600 years. And it has barely rusted. It's just unbelievable.
So how is that even possible? Well, this secret is in the metallurgy. The iron workers back in the 5th century had this process that left a high amount of phosphorus in the iron. And over hundreds of years, that phosphorus reacted with the rain and air to create this microscopic, passive, protective film all over the surface. It's like a self-healing shield that has protected it from rust all this time. It is an absolute masterpiece of ancient materials science.
And their skill with metal wasn't just about engineering, it was about incredible artistry too. They used this technique called lost wax casting to make these stunningly detailed sculptures. Basically, you sculpt a perfect model out of beeswax, cover it in clay, heat it up so the wax melts out, and then you pour molten metal into the hollow space. It's a process they were using over 4,000 years ago to make figures like the famous dancing girl, and it hit its absolute peak with the incredible Chola bronze statues.
Now, all of this stuff, it's more than just cool historical trivia, right? These are the unseen foundations of our modern scientific world. And believe it or not, the connections are sometimes hiding in the very words we speak every day.
Here's a perfect example of that direct line of influence. You know the word sine from trigonometry class? Well, it started in ancient India as the Sanskrit word jaya. Arabic scholars picked it up and translated it as jibba. Then, when that knowledge got to Europe, it was mistranslated into the Latin word sinus, which eventually became our English word sine. You can literally trace its journey across centuries and cultures right there in the word itself. Or think about this. Every time you run a computer algorithm or you solve a problem using algebra, you are using words that came to us through Arabic scholars. And those scholars built their amazing work directly on the mathematical foundations laid down in ancient India. It's incredible. It's history hiding in plain sight, baked right into the language we use for science and tech. So, from the concept of zero to binary code, from rust-proof iron to the very language of mathematics, the influence is just so deep, so powerful, and a lot of the time, totally invisible to us. It really makes you wonder, doesn't it? What else is out there, just hiding in plain sight, waiting to be rediscovered? What other parts of our modern world are standing on foundations that we've completely forgotten?